we're studying oxygen compounds, we might as well close this movie mentioning hydrogen compounds. Start off again talking about the bonding of those, and then when we get into the separate movie we can get specific about them. But again, we can decide the bonding as ionic, network covalent, or molecular covalent. These 7 elements in blue all have hydrides, so sodium hydride, potassium hydride, calcium hydride, and so on, that are very definitively ionic in nature. Okay. However, lithium and magnesium, while you could write them out as being ionic, when we'll see their bonding structure, which we'll see very early on in the hydride movie, they're much closer to being covalent bonds than ionic bonds. And so we've got, first of all, this pretty little sort of bicolor square there, but emphasizing again that diagonal relationship, lithium and magnesium, right? A very important diagonal relationship. We saw earlier beryllium and aluminium, very important diagonal relationship. Okay, talking of beryllium and aluminium, no doubt whatsoever that their hydrides are network covalent, huge, big, expensive networks of covalent bonds. And then all these other ones here are molecular covalent. So boron oxide, the fundamental form of it, much better drawn as molecular covalent. Gallium oxide, same one, despite the fact that aluminium in there has got that network. The oxides, or the hydrides, excuse me, of indium and thallium, not very well characterized. No hydrides made of the noble gases. Now, if you compare this bonding picture with that of the oxides, you can see significantly different, okay, in terms of the pattern of it, in terms of how far the ionic spreads out. So we're seeing here, of course, lithium, beryllium, magnesium, and then aluminium, right? In the hydrides, these all have extensive covalent. Within the oxides, they're definitely ionic. And then these covalent oxides, all of them, without exception, leave us with molecular covalent hydrides. Why is that? Well, the number one reason is, of course, the electronegativity difference, right? The electronegativity of oxygen, 3.5, very, very different from the electronegativity of all these metals here. Hydrogen, on the other hand, electronegativity of 2.1. Therefore, it's very hard to get a huge, big difference in the electronegativity from hydrogen to these metals in order to make it much more of an ionic bond. But again, we will discuss that at more length in the appropriate movies. So here ends the second general movie associated with main groups. There will be a third, possibly even a fourth, depending, of course, upon how popular the third one becomes. Anyway, just pulling your legs. See you in class.